So, Carl, whenever you're ready, the time is now yours. We'll wrap you up just before 1 o'clock, or just before 2 o'clock. So, our next presenter, EM Wave, can get started then.
All right, this is the Survey Technologies Enhanced Capabilities seminar.
Don't forget to share the audio with that also.
Right, I think that was a problem. I'm going to just restart it.
Sure.
Hello.
There we go.
This is Carl Peak, and I'm with Survey Technologies. Here at Survey Technologies, we create coverage testing solutions for first responder and other critical communications networks. The STI Field Test 7 application automates RF signal measurements to verify wireless coverage and quality during drive tests of macro radio networks and indoor tests for fire code and other reasons like bidirectional signal amplifier coverage enhancement. As many of you know, Field Test 7 can interface with your digital radio test set from Astronics and Viavi. However, today I want to introduce you to some of our enhanced capabilities and optional hardware configurations. STI hardware configurations include specific interfaces and hardware including scanners, mobile or portable test radios, and test handsets, which will better meet your application-specific coverage testing requirements. The STI 9400 includes a signal-strength scanner, Field Test 7 application installed on a rugged touchscreen PC, mounting hardware, and Pelican case. The STI 9400 is a very popular solution for scanning multiple frequencies quickly in a single project. The frequency range of the 9400 scanner is 500 kilohertz to 1 gigahertz. Test mobiles available from Survey Technologies will enhance P25 Phase 1, P25 Phase 2, as well as DMR drive test activities by streaming RSSI samples through the Field Test 7 application at a rate of approximately 200 samples per second, meeting all best practices standards for drive test coverage measurements. The test radios also sample BER simultaneously from specific test patterns. Test mobiles are very selective and sensitive, so they will measure the end-to-end coverage and quality of your critical communication system, even in the most demanding RF environments throughout its entire operating range. Tablet PCs and the test portable form factor lend themselves to in-building measurements for fire code requirements and signal amplification efforts like DAS and BDA installations. Customers have used test portables for drive testing to meet coverage requirements that stipulate portable coverage in the macro environment. Test portables are also more sensitive and selective than the other alternatives. Test radios measure BER in Phase 1 from the 1011 pattern. In Phase 2 and DMR require the 1031 pattern for BER measurements. Field Test 7 will interface with our test handsets for LTE measurements of coverage and quality. LTE signal measurements include RSRP, RSRQ, RSSI, and SINAR. We offer test handsets for both GSM networks like AT&T FirstNet and CDMA networks like Verizon. The Survey Technologies Multi-RX Go Case creates an eloquent solution integrating up to 4 test radios into a single-wheeled RF Go Case. The Multi-RX Go Case is designed for test radios of the same or various test bands, even protocol technologies, for use concurrently in a single drive test or individually as test requirements dictate. The Multi-RX Go Case simplifies power and laptop connections to one each for the entire Go Case. Every radio, however, will have a direct connection to a specific RF antenna for coverage and quality measurements due to the multi-frequency, multi-technology GoCase design. The Best Server Quality Measurement, or BSQM GoCase solution, optimizes drive test time for large regional networks. These regional networks are made up of many repeater sites transmitting multiple test frequencies. These tests are optimized by the BSQM testing methodology. One of the radios in the BSQM configuration is used to scan an entire list of test frequencies. When that scan is complete, the 3 strongest frequencies are programmed into the remaining radios in the BSQM GoCase. These quality measurement radios stream RSSI and BER samples to Field Test 7 very rapidly and don't retune. In the meantime, the scanning radio retests all the frequencies to determine the strongest. The 3 strongest test signals are identified and the test radios for quality measurements are retuned again to continue their testing. The BSQM methodology results in an iterative test plan that will test the coverage and quality of the repeaters in your regional P25 network 3 layers deep in one single drive test. If you need to measure the coverage and quality of your network 4 layers deep, just add the STI 9400 as the scanner, freeing up the 4th radio in the GoCase for best server quality measurements. The BSQM configuration keeps antenna clutter on top of the test vehicle to a minimum by combining all of the test radio antenna ports into a single RF antenna. This is a block diagram of the STI 9400 scanner and a 4 radio BSQM system. All frequencies measured can be analyzed independently for their coverage or combined to create a composite wireless network coverage and quality map. Our final GoCase solution is the RxTX GoCase. In this solution, there is a test mobile set up to transmit a 1011 test pattern and a second test mobile set to measure RSSI and BER from the 1011 pattern being transmitted from the site under test. Each radio has its own antenna connection on the RxTX GoCase, and there are extra fans in the GoCase to keep things cool. Field Test 7 and the RxTX GoCase are the vehicle side of a single site P25 Phase 1 uplink and downlink test configuration. At the site, there needs to be another instance of Field Test 7 connected to a measurement receiver for RSSI and BER measurements of the 1011 pattern transmitted from the vehicle. This is a block diagram of the vehicle side of an uplink and downlink P25 Phase 1 test setup. Field Test 7 provides real-time feedback for the testing team while in the field making measurements as tiles are qualified. Just set up 3 levels for acquisition tiles to change color as measurements are accumulated in each tile. Here you can see tiles being qualified in real time during a drive test as the drive test vehicle travels around the area of interest. Another real-time display for the drive test team is the signal display showing measurement results as they are logged. Tile analysis is a menu-driven process. Just select the variable of interest like RSSI or BER or a composite of multiple frequencies for a best server network tile analysis. Verify the tile size, set threshold levels, and Field Test 7 will begin tile calculations. Now that the tile calculations are complete, you can visualize the tile statistics versus the threshold levels that are being used for these calculations. Measurement coverage shows which tiles are qualified with the needed number of measurements in them to validate the tile. Percent above threshold displays each tile's percent of measurements above a threshold level or below a threshold level if displaying bit error rate results. Median values shows the median value of the current variable measurements in each tile. Single tile detail will quickly show a tile's statistics like tile ID, the number of measurements in the tile, the minimum, average, median, and maximum values for the current variable in that tile and the percent of the measurements above the threshold. The tile summary report includes these graphics and the tabular data behind them. The report identifies the tile size and the threshold levels being used, the location of the tile area, and the statistics of each tile just as in the single tile detail. Only now you're able to see all of the tiles' detailed information listed on the report. At the bottom of the report are the pass and fail level summaries. The pass-fail summary includes the number of tiles in the area, the number of tiles tested, the number of qualified tiles which will be used for this report, the percent of tiles with their average, and also the percent of tiles with their median values above the threshold level. Further down at the bottom are listed the number of tiles with all of their measurements above the threshold level, the number of tiles with 90% of their measurements above the threshold level, and so on. GPS is used to locate drive test measurements. However, in-building tests use a geocoded floor plan to reference the measurements in building locations. We have devised a tool to help customers geocode a floor plan from a very simple graphic file or bitmap. Start Building Locator and find the location of the building you want to test on the Field Test 7 map display. Zoom in to geocode and insert your floor plan. Select the floor plan saved on your PC and import it into Building Locator. Next, size and orient the floor plan with the help of the satellite imagery as a guide. Then you're able to remove the satellite imagery, which leaves you with a clean, geocoded floor plan in the Field Test 7 software. Now you're ready for measurements. Start the receiver and confirm that communications has been established. You can switch to the signal display to see the signal levels as they come in. The mobile measurement process begins with marking your current location on the floor plan. Next, you start acquisition and begin walking in a straight line. When you've reached your destination location, you pause the acquisition, mark your location on the floor plan, and then save the buffered measurements. The buffered measurements are spread evenly between the start and stop locations of that mobile measurement segment. Repeating this process, you can move throughout the building, making mobile measurements for coverage studies. Stationary measurements and single measurement modes will help you measure and record signal levels in smaller areas of the building. Indoor measurement results can be displayed in the same way drive test measurements are displayed, with contour plots, measurement exports to Google Earth, and tile reports. There are two types of contour plots, blend and custom, where you can input the levels where colors on the plot change due to grades of service. Once the levels are set, you can quickly create contour plots of RSSI, BER, and other signal variables you have measured. After contour plots are created, they can quickly be exported to Google Earth. Measurement results can also be exported onto Google Earth right from the measurement database. This is an indoor tile report. Here are more examples of Google Earth exports. Thank you for attending the Survey Technologies Field Test 7 Enhanced Capabilities Seminar.
All right, are you able to hear me now? And are there any questions?
Any questions for Carl? Got done perfect timing, so Q&A session here for you. Very informative. Thank you very much, Carl.
Thank you.
And again, if you guys do want to meet, I will post these again in the chat session. We do have the meeting room available for just that purpose. So you can head on over there. You can talk to anyone that's in that room. You can request a breakout meeting to talk one-on-one. So our next presentation is going to start here in just a couple minutes. Our next presentation is going to be EMWave Inc. That's going to be Bruce who's going to be presenting there. So if there's nothing else for
Can you guys
Carl,
hear me?
Yep, I'm going to stop the recording for Carl.